Hello, everyone. All right, so we're going to begin Unit 5 by talking about systems of equations by graphing. So first off, when we're talking about a system of equations, we're talking about two or more equations at the same time. So typically we've been dealing with one equation, we've been graphing it, maybe doing some shading with inequalities, but in this case, now we're going to do two equations or more. So for algebra 1, we're just going to stick to two equations. When you get to algebra 2, you could deal with three or more. So for this first one, we're going to solve it by graphing. So looking at this very first one, I'm giving you two different equations here. So the first equation I give you is y equals 2x minus 1. And then the next one, I give you y equals negative x plus 5. So the first thing that we want to do is identify its slope and the y-intercept. So we're in slope-intercept form, which is just y equals mx plus b. So I can identify the slope and the y-intercept based on the location of those values. So I'm looking for the value with my x for my slope. So for this first equation, my slope here is 2. And then for my y-intercept, you're looking for what it is adding or subtracting. So down here, we are subtracting 1, which means our y-intercept over here is negative 1. Technology is fine. Everything is fine. Hello. There we go. Negative 1. Okay. Now looking at this next one. So y equals negative x plus 5. So we're looking for our slope. So the number in front of the x. So we don't actually have a number here. So because we don't have a number, we assume that's a 1. So we have a slope of negative 1. You have to account for the negative as well. And then the value that we're adding or subtracting at the end, we have positive 5. So our y-intercept or our b value is 5. All right, so now what I want to do is I want to graph both of these equations. So I highly recommend using different colors, at least two different colors, one color for each equation. So I'm going to use purple for my first equation. So I'm going to start with your y-intercept when graphing. So start at negative 1, and then I'm going to apply a slope of 2. So for a slope of 2, for rise over run, that's 2 over 1, which means I'm going to go up 2 and right 1 from my y-intercept. So I need to start with the y-intercept. I'm going to go up 2 and right 1. I'm going to put a point. All right, and I'm going to keep that pattern going. So up 2, right 1, up 2, right 1. So I'm actually being very strategic and putting as many points as possible before I do my line. So there's a reason for that, which will be apparent hopefully in a minute. So before, you could just do 2 points graph your line, but I'm going to be very strategic by placing every point possible. All right, so now for my equation in blue, so now I want to start at 5, and then I want to do a slope of negative 1. So for a slope of negative 1, that means I want to go down 1 and right 1. So I'm going to start at 5. All right, so I'm going to go down 1, right 1. So down 1, right 1. So there's my other point. All right, so I'm going to go again, and notice how this blue and purple point, now they're overlapping. All right, so I got the point where they overlap, so the rest of that is fine. I'm going to draw and extend my line. Now I need to draw my purple line. Or try to. With arrows, there we go. All right, so I'm really focusing on the point of intersection. So the point of intersection right here, this is what we're going to call the solution. So wherever they cross, that's what we call a solution to a system, because that point where they cross is on both lines. So it satisfies both equations, which is what we're looking for in a system, a point that satisfies all the equations involved. So that coordinate right here where they cross, that would be 2, 3. which means 2 comma 3, that is my solution. So that is going to be your answer. So your answers here, your solutions are going to be an ordered pair. They're going to be a coordinate. All right, so whenever we are doing systems of equations by graphing, if you think back to prior lessons, we've also had lines that are parallel. We've also had lines that are overlapping. So in terms of systems, those all have different meanings. So if we have one solution, that means they're going to intersect at exactly one point. So their slopes have to be different. Their y-intercepts, they don't matter. They can be the same or they can be different. And just like above, that's what it could look like. So it's kind of a similar example. However, if we have something like no solution, it means these lines are going to be parallel. It means they do not cross at all. So that means their slopes are going to be the same, where their y-intercepts must be different. They cannot be the same. It is imperative that they're not the same. So if you have parallel lines on a graph, that means there's no solution, there's no intersection, so this system would not have a solution. All right, now looking at this very last one, it's what we called infinitely many solutions, or IMS. So you could also see the symbol for all real numbers or have it written out. There's a whole bunch of different ways that we could write infinitely many solutions. So what this looks like is 2 lines overlapping. So even though there's 2 or more lines on a grid, it only looks like there's 1 line, which means those are going to have the same slopes, the same y-intercepts, and those lines are going to be overlapping. So for the sake of the notes, I tried to make it clear that there were 2 different colored lines that were overlapping. However, on a grid, like if you put them on Desmos, you're not going to see the 2 different colors like this. You're only going to see 1. But those lines are overlapping. All right. So now looking down here, we want to determine the number of solutions of the, nope, I can't read. Everything's fine. We just want to determine the number of solutions. So looking at this very first one here, we have y equals 4x plus 3 and y equals 4x minus 3. All right, so looking at this top equation over here, so I have a slope of 4 and a b value of 3, or y-intercept. So for my second equation, I have slope of 4 and a b value of negative 3. So if you look here, we have the same slopes, but different y-intercepts, which means we have same slopes, but different y-intercepts, which means these are going to be parallel, which means there's no solution. So down here, no solution. All right, now looking at this next one here, we have y equals negative x and x plus y equals 0. So what I'm going to do, since both of these equations are in different forms, so for example, the top one here, this is in slope-intercept form technically, and then this equation down here, this is in standard form. So I want to convert. So I'm actually going to convert my top equation to standard form. Although if you want to convert the bottom one to slope-intercept form, that works as well. So I have y equals negative x. So what I'm going to do is I'm going to add x on both sides. So when I do that, I'm going to have x plus y equals 0. So if you notice, when I converted, both of these equations are the exact same thing, which means they're going to have the same slope and the same y-intercept, which means this is going to be IMS, infinitely many solutions. All right, and looking over here at this very last one, now we have y equals 3x minus 2 and y equals negative 3x minus 2. So looking at the slopes, so I have slope of 3 in my top equation and a b value of negative 2. Then down below, I have a slope of negative 3 and a b value of negative 2. So we're really looking at the slopes first. So notice how the slopes are different. They're not the same, which means they can only have one solution. All right. so this little quick reference chart for you is really going to make a big difference for you guys on these problems like these, when you just want to determine the number of solutions. All right, so the next set of problems is where you're actually going to be graphing and you want to determine the solution. So we're actually going to start with number 2, just because they're both in slope-intercept form already. All right, so for this first one here, we have y equals 2x minus 4 and y equals negative x plus 2. So I'm going to start with the slope. So we have a slope of 2 and a b value of negative 4. Then for my equation below, we have a slope of negative 1 and a b value of positive 2. So just like before, I'm going to plot as many points as I can until I find those points that are overlapping. All right, so I'm going to graph my line in blue first. So I'm going to start at negative 4, do a slope of 2, which means up 2, right 1. All right, now I'm going to go the other way. So I'm going to go down 2 and left 1. So there's all those points. All right, so I don't want to draw the line just yet, because now I want to do the equation in red. So I'm going to start at 2 for my y-intercept and then do a slope of negative 1. So down 1, right 1. So there's my overlap right there. All right, so now that I found my overlap, I'm going to go ahead and just draw my line. All right, so as mentioned before, we're really interested in where they intersect, where they cross. So that coordinate right here, where they cross, that is 2, 0. So that is my solution. All right, so now let's jump back over to number 1. So this equation here is not necessarily in slope-intercept form, at least the second one's not. However, the first one is. So I'm going to start with the first one here. So we have a slope of 1 and a b value of negative 7. All right, so now I need to convert my bottom equation to slope-intercept form. So I'm going to rewrite. So I have 4y equals negative x minus 8. All right, so what I'm going to do is divide everything by 4. So I'm going to have y equals negative x over 4 minus, that's not a 4, minus 8 over 4. So now I just want to kind of simplify, clean it up to make it a little bit more obvious what my values are. All right, so I'm going to move the negative out front, move the x to the side. So my value here is 1/4. And then negative 8 over 4 is minus 2. All right, so my equation here is y equals negative 1/4 x minus 2. So my slope is negative 1/4 with a b value of negative 2. So I'm going to start with this one. So go to negative 2. Now I want to go down 1 and right 4 for a slope of negative 1/4. All right, so there's all those points. All right, so now I want to do my equation in purple up there. So I'm going to start at negative 7. And I'm going to do a slope of positive 1, so up 1, right 1. So there's my overlap. All right, so now I'm going to go ahead and draw my line. So there's our solution and that point. Let's see if I can count. So 4, -3. So that would be our solution here. So in reality, there's really not anything new per se that we're doing conceptually. The only new thing is now we're just going to be graphing two equations and we're just looking to see where they cross. The graphing component of this should all be a review. However, if you're still struggling with graphing, then you definitely need to come in for tutoring. All right, so I would say try these two problems on your own. So you can pause here, try it, or you can just let it keep going. So for number 3, so our first equation here is in slope-intercept form. All right, so our slope is 2 and our b value is 1. So with the equation, our second equation here being in standard form, I'm actually going to go ahead and just do the standard form trick to find the x-intercept, y-intercept, and the slope. So to find the slope, it is the opposite of a over b. To find the x-intercept, it is c over a. And to find the y-intercept, it is c over b. All right, so we have an a value of 4, b value of -2, and a c value of -2. So based on these values, so -4 over -2, which simplifies to give me a slope of +2. Now for my x-intercept, so I'm going to do -2 over +4, which means I'm going to have a x-intercept of -1/2, which that's not going to be very easy to graph. All right, so now for my y-intercept, so now I have c over b, so -2 over -2, which is +1. All right, so let's start with the equation in red. So I'm going to start at 1, apply a slope of 2. So up 2, right 1. All right, then for my other equation down here, let's use blue. So I'm going to start with my y-intercept, which is at +1. So I'm going to go to +1. So we have an overlap already. And I'm going to apply a slope of 2, which means up 2, right 1. So if you notice, every single one of these points is going to overlap. So if I'm going to go the other way, I got to go down 2 and left 1. So every single one of these points is going to overlap, which means this is really only going to look like one equation. So since every single point is overlapping, that means your solution here is IMS, infinitely many solutions. Or you could write all real numbers or the symbol for all real numbers. It's really up to you. It all means the same thing, tomato, tomato. All right, so for number 4. So for the top equation, y equals 3x minus 2, we have a slope of 3, b value of -2. Now I want to look at my other equation down here. So yeah, let's go ahead and do the trick again. All right, so my m value is the opposite of a over b. So -3 over -1, which is +3. Now for my x-intercept, which is c over a. So I'm going to have 2, that's not a 3, 2 over 3, which is not really graphable. So you really only want to look for whole numbers for graphing. If you get a fraction of any sort, you can't necessarily graph that by hand very precisely. So now for the y-intercept, so now c over b, so 2 over -1, which simplifies to -2. All right, so let's go ahead and do this pink or purple or whichever one it is. So start at -2 and do a slope of 3. So up 3 and right 1. Up 3, right 1, up 3, right 1, up 3, right 1. So to go the other way, down 3, left 1, down 3, left 1. All right, now my equation in green. So I'm going to start at -2. Those should not be the same. So these are going to be overlapping based on this. However, let's say I change this -2 to a +2. So this is now just a y-intercept of +2. That's what that should have been. All right, so start at +2, then up 3, right 1, up 3, right 1, up, now down 3, left 1, down 3, left 1. All right, so this is what it should have been. All right, so these equations do not cross at all, which means our solution here is there's not one. So this would be no solution. All right, so this is just if I made this change right here, change that to a positive, that should have been a positive. Okay, now moving on to the next section. So in this case, now instead of I give you the system and I want the graph, now I actually give you the graph of the system and I want the system in return. So when I say write the system, you want to write both of those equations. So it doesn't matter which one you do first. So over here, you have this green line and this blue line. So you want to write both of these. So I'm just going to start with the green line. So I'm going to start with my y-intercept. So I know my b value is equal to 10. Now I want to find the slope. So I want to find the rise over the run. So you're going to look for clear, concise points. So my advice is use the intercepts if possible. So I'm going to use the y-intercept down here. And it's going to go all the way down to the x-intercept, which means we're going to have down 10 and right 10, which means your slope here is -1. So if you really want to just go down 1, right 1, you can. Just be sure you're looking for clear, concise points. All right, so it's looking at the blue line next. So once again, I'm going to start with the y-intercept. So my y-intercept is here. So this is going to be at the point. That's not a b. That's a b. 0, 3. So my b value is 3. Now I want to find the slope. So once again, I'm going to do the intercepts. So I'm going to do my rise over my run. So I went up 3 and right 4, which means my slope here is 3/4. All right, so I'm going to write the equation for purple. So I'm going to have y equals -x plus 10. Then my other equation, so y equals 3/4 x plus 3. So that would be your system. You're writing the equations for both. So really use the intercepts to your advantage if you can. You could also use their solution as another point where you could use. All right, now looking at the next one. All right, so let's do the equation in orange first. So my y-intercept here, that is 6. All right, so now I'm going to do the slope. Try to. There we go. So once again, I'm using the intercepts. However, if you don't want to use the intercepts, you are free to use whichever points you are inclined to use. All right, so that's going to be up 6 and right 6, which means my slope here is 1. All right, so now I'm going to do the equation down there in purple. Let's use blue. All right, so once again, start with the b value, your y-intercept. So it's a b value of 2. So now I want to use the intercepts, and I'm going to find the slope. All right, so I went up 2, and then right 4, which means my slope here, 2 over 4, simplifies to 1/2. All right, so my first equation is going to be y equals x plus 6. Then my second equation, y equals 1/2 x plus 2. So that is my system.